Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the May-June 2020 Pure Mathematics P1 paper. This is the paper 1 variant 1 from the 9709 Cambridge syllabus. And here we have a question about equations of circles. So it says the coordinates of the points A and B are -1, -2, and 7, 4 respectively. So you have A, -1, -2, and B, 7, 4. It says find the equation of the circle C for which AB is a diameter. Okay, so we have a circle, and I'm going to make a little sketch just to make it clearer. In this particular question, or this part of this question, it doesn't really require a sketch, but I would advise you to take a compass and a ruler definitely with you to the exam, in case you might want to sketch certain special circle questions, which might help you. And it's a bit messy when you try to draw a circle freehand. So having a compass would be useful in the P1 exam for that reason. Okay, so we got the circle center C, and AB is the diameter. So I'm just going to make a quick kind of a basic. So if A is minus, so the diameter will look something like this. Of course, it passes through the center of the circle. Okay, and it's going to be something like this. Why? Because this is 7, 4. This is the point B. 7, 4, and this is the point A, -1, -2. So we want to find the equation of the circle C. How do we find the equation of a circle? Well, we need two things. So for the equation of a circle, we need two things. One thing we need is the center of the circle. We need to know the coordinates of the center of the circle. Let's call it AB. And the second thing we need to know is the length of the radius of the circle. Let's call it R. Okay, we need to know the length of the radius, and we need to know the center. If we know that, we can use the formula x minus a squared plus y minus b squared is equal to r squared. Okay, so it's x and the opposite sign of the a, whatever, basically the number you put here is going to be the opposite of what you see in the equation, in the coordinate for both both x and y. So x minus the x coordinate squared plus y minus the y coordinate squared of the center equals r squared, which is the square of the radius. Okay, so if I find the center and the radius, I can fill this in, and I've got my equation. So how do I find the center and the radius of the circle? Well, this is the diameter, this is the center. The center is the midpoint. C is the midpoint of AB. Okay, so C is the midpoint of AB, and we can use the fact it's the midpoint of AB to find the coordinates of C, because we know the midpoint is found by the average of the x coordinates and the average of the y coordinates. So we're going to have to add the x coordinates together. So -1 plus 7 and then divide by 2. That's the x coordinate of the midpoint. And the y coordinate, you're going to have -2 plus 4 divided by 2. So that gives us the coordinates of the center are going to be, that's going to be 6 over 2, which is 3. And that's 4 minus 2, 2 over 2, which is 1. So those are the coordinates of the center of the circle, 3, 1. So now we can write down the equation. Well, now we have to also find the length of the radius. Now the radius is equal to a half of the diameter. Okay, so I could find the distance between 7, 4 and 3, 1, or between -1 and -2 and 3, 1, and I could get the length of the radius that way. But because 3, 1 is something we calculated, maybe we made a mistake there. It's better for us to use what's given. So we know the diameter is 7, 4 and -1, 2. Those are the ends of the diameter. So the length between those two will give us the diameter, and half of that will be the radius. So I need a half of that diameter, so I'll have a half times, and to find the distance between 2 points, we can use Pythagoras' theorem, which is what the distance formula is all about. So we find the change in the x coordinates, so 7 minus -1, and we square it, plus the change in the y coordinates, which is going to be 4 minus -2, and we square that and find the square root. So that's going to be a half of, we're going to have, that's going to be 7 plus 1, which is 8 squared, plus 6 squared. That's going to be 100. So it's going to be a half times root 100. Okay, which is going to be a half times 10, which is 5. Okay, so the radius is equal to 5, and the center is equal to 3, 1. So therefore, our equation is x minus the x coordinate squared plus y minus the y coordinate squared equals the radius squared, which is 5 squared, which is 25. And there we have the answer to this question, part A, part 10, part A. Okay, so that is the equation of the circle. Now we're going to go on to part B. And now we have to find the equation of the tangent to the circle at the point B. Here we have some of the information from the previous part of the question. So we know the coordinates of A, B, C, C being the center of the circle, and we know the equation of the circle. Now we want to find the equation of the tangent to the circle at the point B. So again, if we just make a little quick diagram. Always good to picture what's going on in these type of questions. Always a good idea. Okay, so I'm going to make a little circle, and we have our points that we mentioned. We can call that, that's C, that's B, and that's A. Okay, so we join them together. Now that is the diameter of the circle. This is the center of the circle. Okay, now there is a line which is called a tangent, which will pass through this, or which will just touch a part of this shape, okay, at B, or touch it at B. Okay, so a tangent is a straight line which shares the same gradient of the circle at the point at which it touches it. Okay, so this is T, the tangent. There's a right angle. Now what we have to understand is that the tangent and the radius will always meet at right angles at the point at which the tangent touches the circle. So the angle here is going to be 90 degrees for sure. Okay, the tangent meets the radius 90 degrees at the point where the tangent touches the circle. And that's going to help us a lot in this question now, okay, because we want to find the equation of the tangent. To find the equation of a straight line, we need two things. Just like with the circle, we need two things, but here we need two different things. One, we need the gradient of the line, which is always the same. And two, we need a point on the line. Okay, so we have the point on the line, which is 7, 4. That's a point on the tangent. That's the only point we know that's on the tangent. How do I find the gradient of the tangent? We only have one point in it. How do we find the gradient of it? Well, from the fact I mentioned just now, the tangent and the radius meet at 90 degrees. So I know that this angle between, for example, this angle here between BA and the tangent is 90 degrees. So they're perpendicular. So if I can find the gradient of the line AB, then the gradient of the tangent will be the perpendicular line to it, which is easy then to work out its gradient. It's a negative reciprocal. So if I take my points as A and B, because those were given and not calculated, and I find the gradient of the line AB. So let me find the gradient of the line AB. The gradient of the line AB is going to be the change in y, which is 4 minus 2, over the change in x, which is 7 minus 1. That's going to give you 4 minus 2, which is 4 plus 2, which is 6, over 7 plus 1, which is 8. So that's going to give you 3/4. So that is the gradient of AB. So therefore, the gradient of the tangent is going to be the negative reciprocal of this, which is minus 4/3. Okay, so now we have what we need to find the equation of the tangent. We know the point on the line, which is 7, 4. We know the gradient, which is negative 4/3. Okay, and we can find what we need. Okay, so those are the two things that we need to find the equation of a straight line, 1 and 2. Okay, so let's go. We know the gradient, the equation of a straight line, y minus y1 equals m times x minus x1. So we have, this is one formula. A lot of people like to use the formula y equals mx plus c. Both of them are perfectly fine. I much prefer to use this one when we have, fractions in the, especially for the gradient. So you have y minus 4 equals m, which is negative 4 over 3, times x minus 7. So here we can rewrite this. I would like, we can rewrite this in two forms. We can write it in the form y equals mx plus c, or we can write it in the form ax plus by plus equals 0. Both of those are fine. I'm going to multiply both sides by 3 to get rid of the fraction. 3y minus 12 is equal to negative 4x plus 28. Okay, so we can bring everything to one side. 4x plus 3y, and you're going to have minus 40 equals 0. Okay, that's going to be 28 plus 2 is 30 plus n 40. Okay, that's one form of the equation. We could have also put y is equal to minus 4 over 3x. Okay, minus 4 over 3x. And then you're going to have plus 28 over 3. And that would be plus, why is it 28? No. 28 over 3 plus, it's going to be plus 40 over 3, sorry. Okay, we could have it as plus 40 over 3. Rearranging this. Okay, we could have found the answer using y equals mx plus c like this, and it would have been fine. We could find what c was, and then continued. I prefer to use this especially when I'm dealing with fractions in my gradients. Okay, so there's part B done. It's quite a standard question. Find the equation of the tangent t. Now for part C, now here you have to do a bit of thinking. It says find the equation of the circle, which is the reflection of circle C in the line T. So I'm going to just draw my line T. I'm going to draw a circle. Okay, and I'm going to, oops, I don't want a triangle, I want a circle. It's supposed to be from here. Okay, so I'm going to draw a circle. I'll make it a bit smaller so we can see what's happening. Say that's the tangent. Now this circle, if it's a reflection of itself in the tangent, it will be identical, okay, to the original. So a reflection is where the object and the image are identical, they're congruent, okay, and they're just reflected along the mirror line. The mirror line passes through the point B, the tangent. The mirror line is the tangent line. So if I take this and I copy and paste it, okay, I'll have like a mirror image of it on this side, and this is B. This is the reflection. Okay, so this is the point B, which was 4, 7. That's what we were given. Okay, oh sorry, 7, 4, my bad. That's 7, 4. This is the center of the original circle, which was, we found it to be 3 and 1. 3 and 1. And we need to find the coordinates of this point over here. Let's call it xy. So basically what we have is this point here is halfway between them, because this is the radius, this is the radius, they're equal. So this line here that we have, the tangent, is basically a line which cuts the distance between those two in 2 equal halves and at right angles. So we can use that to find the equation of the circle this side, because I know the radius of the circle is still 5, but I know I can find this center. The center of this is xy. So xy is like the end. It's like the 3 points, it's like the end point, xy. The initial point is going to be the point where this point here, which is 3, 1. Okay, and exactly halfway through between these points is a point B, which is 7, 4. Okay, so if I can find the value of x such that this is the midpoint between these 2 points, the same for y, I have found the coordinates of the center of the circle, this new circle, and then I can find this equation very easily. So I'm going to think about this in 2 ways. A logical way of thinking about this, is 3 to 7, you have to add 4. So 7 to x, you have to also add 4 because it's like symmetrical. That's going to be 11. And 1 to 4, you add 3. And 4 to y, you must also add 3. So 4 plus 3 is 7. So it should be 11, 7 as our answer. That's a nice, easy way of doing it, the way I showed you just now. There's also another way of doing it, which is more algebraically, kind of like, kind of more of an algebraic way of doing it, where we say, okay, 7 is a result of being the midpoint of 3 and x. So how do you find that? If it was one of them was unknown, you have 3 plus x divided by 2 equals 7. Okay, and similarly, for y, you can do the same thing. You can say 1 plus 4, okay? Sorry, not 1 plus y. 4. 1 plus y divided by 2 is equal to, okay, 1 plus y divided by 2 is going to be the y coordinate of the center, which is 4. Okay, so that will help you find our value of x and y. As you'll see, hopefully we get the same answer that we got earlier. So 3 plus x over 2 equals 7. So 3 plus x is equal to 14. So x is equal to 11. Okay, so we know that's correct. And then we have 1 plus y over 2 equals 4. So 1 plus y is equal to 8. So y is equal to 8 minus 1, which is 7. So 11 and 7 are, as we determined earlier using this quicker method, that's the x and y coordinates of the center of the circle. So we know that 11, 7 is the center. We know that r is equal to 25. So we can say now the equation of this new circle, the reflected circle, is x minus 11 squared plus y minus 7 squared, sorry, not 17. Plus y minus 7 squared is equal to 25. And there we have the answer to this question. I hope that was clear. Okay, that last part was slightly tricky, but you have to just remember the properties of reflections. When something's reflected in the mirror line, then every point is the same distance away from the mirror line on the opposite side of the 90 degrees to the mirror line. Okay, so this center has been reflected exactly to the other side with the point B as its center. Okay, so there's the answer to this question. I hope that was clear, and I think that was the last part of this question. That's right. So other questions from this paper can be found in the playlist that will appear at the top right of the screen at the end of the video. Other questions from the topic of circle equations, all under circle equations. You find that at the bottom right here. You can subscribe to the channel if you wish to by clicking on this link here. Thank you for watching and see you soon.